So converting between English or imperial units can be unpleasant. Right? The calculations aren't really hard, but there are just dozens of conversion factors you need to know, even if you're just sticking to common measurements like feet, cups, and ounces. The metric system, on the other hand, invented in 1670 by Gabriel Mounton, a church vicar in Lyon, France, was developed to solve this problem. In the metric system, there's only one conversion factor, the number 10. All right, so here's the basic idea. The metric system is based on a list of prefixes that get put in front of the base unit. For example, the base unit for measuring lengths is the meter, right? So we can talk about kilometers, hectometers, decameters, the original meters themselves, decimeters, centimeters, and millimeters. Now, I've got the symbols for each abbreviation here in the middle column, and what each one means in the right-hand column. Now, notice how each measurement is 10 times more or less than the previous one. For example, 1 decameter is 10 meters. 1 hectometer is 10 decameters, or 100 meters, etc. Now remember, multiplying or dividing by 10 is equivalent to just moving the decimal place of a number. For example, 1.52 times 10 is 15.2. Right? 1.52 times 100 is 152. Right? And similarly, if you wanted to divide 1.52 divided by 10, I'm making the number smaller, so I'm going to move the decimal point to the left, and this becomes 0.152. All right, so let's look at some examples. Right? How many meters are there in 2.4 kilometers? Right? Okay. I know that I'm trying to go from 2.4 kilometers to meters. So what I've got here, I've got all of the prefixes written out. Okay, now remember, going up or down is just multiplying or dividing by 10. So I want to go from kilometers to meters. Right? Well, I changed by a factor of 10 here, 10 again, and 10 again. Right? So I've changed my number total by a factor of 1,000, which means I'm going to move my decimal point 3 places. Right? So the big question now, which direction do we go? All right? Well, the easiest way to remember is if you've got the prefixes written the way I did here, is the decimal point goes in the same direction that you counted the places. Right? I went from left to right, so I'm going to move my decimal point from left to right. I'm going to start with 2.4 and go 1, 2, 3 places, and that's where it ends up. And I'm going to fill in zeros here in those blanks. And there's my answer. 2.4 kilometers is equal to 2,400 meters. Right? Another way to look at it, if you don't have this list in front of you, is to think about relative size. Right? Meters are smaller than kilometers. That means it takes a lot of meters to fill up a single kilometer, which tells me that my final answer has to be bigger than the original one. All right, so let's try another one. You can pause if you like. Try this one on your own. All right, then start this up again, and we'll go through it together. All right, so I want to know how many hectometers are there in 105 centimeters. So I'm going from centimeters, 1, 2, 3, 4. Right? I'm going 4 factors of 10 to get between these two. Now, so I'm going to start with 105. Right? And which way am I going to go? Well, I went from right to left here. So I'm going to move my decimal point from right to left. I'm going to go 1, 2, 3, 4, and that's where I end up. So 105 centimeters is equal to 0.0105 hectometers. Right? That's my final answer. Okay, so where are we going next? So now that we've got these things that what are called linear measurements, right? Talking about feet in the imperial system, meters in the metric system. The next step up is to think about two-dimensional figures, right? So in the next lecture, we're going to talk about area, and then we'll take the next step up there as well, go up to 3 dimensions, and talk about volume.